So this is a preview of a Grasshopper setup, which I refer to as attraction circles, and you see on the screen right now an animation which is made to explain a little bit and to visualize what's happening. So what's going on here is a coordinate which is attracting the transformation of all these circles. What actually then happens in Grasshopper is that every time this cursor down here is moved or repositioned, it measures the distances to each and every point, and this distance is then a number which is fed into each circle and gives this very circle its radius. Of course, it's manipulated because you see it's a kind of wave shape going on. Also, the distance would be much too large, of course, for this very small circle, so that's manipulated too. So I'll show you how this looks like in Rhino and Grasshopper. So here you see the setup. It's all based on a grid, which is this point here. You see the grid component is turned off. It's not previewed. So when I here I see these are more or less all the planes or the placeholder for each and every circle, right? And I also made you can set the resolution of it like this, and you can of course transform its proportions. So I can take out that. What we also have is two sets of algorithms. The upper part here is the one I'm gonna talk about first, and the lower part is a little bit of an extra, I would say. So I'll come to that. So the first one here, you can't see anything. It's because the coordinate that I showed you on the previous picture, this one moving down here, is not there because the point component here is orange, which means it's empty. So we need to put something in there. So I can make, like, for example, 3 points here, and I go to my component in Grasshopper and set multiple points. Right click, set multiple points. Then I right click again, and then the pattern appears. So every time I move the coordinates here in the Rhino space, the pattern transforms. And this is of course quite handy because you have design-wise kind of a hand-built model, if you will, direct modeling combined with a parametric modeling. This you see is a distance component here. So from each and every point we measure the distance to each and every coordinate in Rhino space. And they have to be grafted, of course, because otherwise it wouldn't measure the distance to each and every point. So all these distances are then mass added together in a mass addition, going into a graph mapper here, and I've applied sinus to it. You can have actually quite many different graphs, which will of course transform the appearance of the pattern. So we manipulate this, and the sizes of the circles and where that is gets also manipulated accordingly. So a high frequency turns into something like this, while a low frequency with long waves turns into something like this. I also applied a general modifier of the radiuses here. So you see all these numbers, all the distances, getting them manipulated on the way goes into the radius of the circles here. So then I've explained the first part here, and the second part is actually if you don't want to have a rectangular shape like this, maybe you want to have something like this. Maybe this is your design. Let's say it's your design, looks like this, and you want this to occur only within this, right? So then we can actually take this curve into Grasshopper and tell Grasshopper to limit the pattern to only exist within this curve. So I'll take that in, you will see how that looks like. And I have to rebuild a little bit first here, for example, like that. So now you see how it looks like when it goes all the way to the edge here. So it's limited by the shape we drew. But what if you wanted to have a fade out? Because this is very handy, of course. But the fade out part is, from my experience, very convenient to have. And with a fade out, I mean that they actually disappear according to a specific distance from the edge of the curve. And that's what this is for. Another graph mapper with a Bezier curve. So let's say that if I can turn this on, maybe it's more understandable. So we again we measure distances from here is, for example, curve closest point. So it measures, it finds the points from the grid here. It goes, you see, it's the same. It gets channeled here through first. Excuse the setup here might be, it's a bit crisscrossy, but it's because I want to show both workspaces on the screen. So the closer you are to the curve, the closer one of these points is, that gets channeled through like this, it's going to be affected by this curve. So let's say that here in Origo, the Bezier curve is here is the curve we drew, right? So that's going to be a lot of zeros because Origo is 0, 0, and it gets then multiplied with the distances. And if I put that into the radiuses, then it's maybe more understandable what happens here. Right? I can turn this off. So now you see a fade out. And when I move and transform my curve again, the fade out continues or follows the shape of the curve with a specific distance from it, as you see. Can take like that, and you can also manipulate then the Bezier curve. So if you keep an eye on the edge here and what I'm doing here in the same time, if I pull it up, they appear again, and that's because of course Origo here is not 0 anymore, it's 1 in the y-axis, which means that the radius of the circles close to the curve actually gets a parameter. Before it was 0, and so a circle was not made. I can pull it down like that, and I can manipulate this other axis here to reshape the Bezier curve more or less. You see how it's reshaping, and then of course the fade out also gets manipulated. And we can also have a longer distance from the curve by doing this. We just extend the x-axis. So if I pull down here now, for example, it completely disappears. So you go back like that, and you can also go like that. In this case, I think 0 to 10 in the x-axis is actually better. So this is something that one has to set along the way, depending on what you design. In the following videos, I will show how to do this step by step. So please look at those videos. Thank you. So the first thing you will need is a grid, so which you will find under vector. You go to grid and you open a rectangular grid, for example. You can also have a square grid in this case, but let's take a rectangular grid. And usually I build this based on a resolution setup. That means that I don't have to this doesn't happen, that it goes back and forth when I change the settings. Rather, the proportions are completely static like this, and only the density of the points are altered. So then you have to divide the length, the sizes of the cells with number of cells. So what you do then is that you simply open here a slider, and we can right click on the slider and give it something like maybe minimum 0 and maximum 10. That is for the sizes. So we can put that into the sizes already, like that. Let's see if something happens. Yes, here we have something, because if you hover, you see this is the sizes, of course. That's 249 saying here, and on the number of cell grids in X and Y direction, it's a preset, so it's 10 and 5, right? So let's take some new sliders, and for the number of grid cells, we right click and let's make it maximum 100. We can take an integer number on that too, because we don't need any decimals. And as you know, 0 doesn't work, so minimum 1, because there can't be less than 1 cell in each direction. So if we add that, you see that we have one of those patterns, grids. And one of those grids that I did not want to have, actually. So what I need to do now is to simply divide this number with that number. So if I go to math and operators, there are the division here. So if this goes too fast, you know about Control Alt and click on the left mouse button, then you find all the things here. So if I go to maths again, and operators and division, here's the division component. It simply divides a number with another one. So I click Control Alt and left click. There you see where it is. So if I divide this with that, like that, and put it in here, something completely different appears, of course. If I increase this, you see it increases as well, but if I start doing this, you see the difference, right? The width is constant, more or less constant at least. So if I copy this and put it into the Y as well, now we have a good setup for resolution. Now it's 15 by 15, more or less. If you hover here, it's going to see something else, right? So it's 7.6 something. It reads it as 8 because it simply converts floating numbers into into an integer, of course, because you cannot have 7.5 cells. Anyway, this setup is pretty good already. You see the grid is going down like that quite nicely. And then we need to attach something to this to use the points, and that is the circles. So if you double click and simply search for it or Google for it, the circles come up. So the circle with the black hexagon in behind, that's the only representative component, and this is a construction component. So here you construct a new circle inside Grasshopper. And there's a P, of course, base plane of circle, and here is also a P, so points at grid corners. And this is the one we're going to use simply. So we just put it in there, and then you have circles all over the place. But we are supposed to manipulate the sizes of these because they're all the same now. What we can do now, by the way, is we can hide the grid. We don't need to see it. So you right click and you go to preview. So now it's gone. Now we only see the circles, which is quite nice also, but that's not what we're going to do. So we need to take in a distance measurer. If you double click and Google distance, then it comes up. So we're going to measure the distance from from the point corners to points in Rhino space. So let's do a couple of points here. Take this first one, a single point with a left mouse button, and you click them out like this, for example. And then you go to parameters and take one of these point objects, point components that are representative, so to say. I mean, you don't really construct a point. You just you pick it from Rhino workspace. So you right click and it takes set multiple points. The window disappears and you simply select them like that, and then they're in. So now it's measuring already. Then you can actually just test, put it in there, and then you see what happens. It becomes very large. And the thing is, this is correct, you know. And the more you pull it away from the grid, which is not even visible, the more the larger they get, because the distance between the points and the grid sets the radius of the circle. So that's we have to, of course, manipulate this number. So you can take this away by holding Control and pull it back, like that. So what we can do now is to mass addition. Why do we do that? Well, it's because we need to summon all the lists in that are being channeled through distance measure here. But currently, they're actually using the points here as one distance measure. It's not measuring to each and every point, because this input is not grafted. So if we right click and graft, now we have a much more complex list with distance measuring from each and every point from these 3 points. So it's like 3 sets of lists, more or less. So that will be complicated because they are stacked on top of each other. The lists is quite hard to explain, which will the explanation will take place in a different way, in a graphical way later. So we need to add the numbers together. So if we double click and search for mass addition and hold it in there, then we have a much better situation, which I will explain at another occasion. What we need to do then is to open a graph mapper. So double click and just search for graph mapper. Here it is. It comes out like this. So you have to select something, select which one you want to use. So let's use sine wave, like that. And I know now on beforehand that we have to alter the highest numbers to be able to see anything. So if I double click and instead of 0 to 1, I go to 0 to 20 and to 0 to 20. So this is a good proportion, which I know already. This is something that you will have to test a little bit with. So if I now put it in, that happens. It's huge, absolutely huge. So we need to take in another division device here. So go to math and divide, because it's actually correct already, but it's just too large. So, and then we take in all those values into the division device here, and we have to divide it with something. So let's pick this one, for example. I remember, I do copy paste here. So I remember it's from 100, so that's a pretty good way of doing it. So now something's happening. But what's going on? What's up with this visual appearance? Well, it's not grafted. It's the same thing. You see here it's grafted. It's different lists than this one uses. So we have to graft this input as well. Then it should be fine. So there you already have a good setup, and now you can try and play along with that. So this is the end of part 1 of the attraction circles. So what we're going to do now is to make a selection of points within a curve that you draw. So we will start with simply drawing a curve. So it could look like something like this. Like that. And we need to put that in. So we go to parameters and go to curve. And right click, set one curve. And now it's inside. What we need to do now is to simply determine whether or not these points are inside of this curve, which you can do with something called pointing curve. So if we go to curves, analysis, and pointing curve, test the point for closed curve containment. Just take that out and let's hover and see what it says. So point for region inclusion test, that's definitely this point. By the way, something very interesting here is that you can double click on the cable and simply attach these to other components, and then it's the same information going out. So I do that, and now we need to have, look here, boundary region closed curves, only we have a curve, so that's the one we need. But what does it give us? It gives us something here. Yes, this is very important to read. Especially it's the top output which is most important to us. So 0 means outside, 1 means coincident, 2 means inside, and 2, that's what we're looking for. So but how do we select that? I mentioned previously that true and false commands are quite good to use. So call pattern, for example, is something like that. Call and list item, they are working with Boolean parameters. True and false. So if we double click and type CULL, call pattern, we see that it is the list that is going to transform, and it needs a pattern. So if we we should use the points, and something happened there. It's because it's false, false, true, true. So it's like false, false in that row, true, true, false, false, true, true, and so on. But this only gives us a number, actually. So we need to go to equality or larger than and things like this in operators, because these transforms numbers into true and false. They're actually comparing things with each other. So if we take equality, located here, we compare the first number to the second number, and if they are the same, it will say true here. It's quite interesting. So we take R in there, and we take a panel and simply type 2. We can make that a little smaller, and goes in there. And now we have a lot of different things going on. So if we again take a panel and look at that, you see that it's correct. It says false, 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 true, true, and so on. This can then go into the call component, and voila, you have a selection. What's weird now is that the circles are outside. It's because we have transformed the placeholders, the center points for the circles. So we need to simply use these instead for the circle. Now we put that in there. And now it's still a bit strange. Basically also because the points are visible, so we can hide this one, and you see this looks very weird, and it's because the distances are still measured from this point, and they should measure this one instead, right? So we put that in there as well, and there you go. Then you have a selection, and now you can start to pull this back and forth. Remember that you have a grid in behind, so if you go outside of the bounds, the selection won't really work. Then you will have a limit, a border to it. But what we wanted to do here is also to make this gradient fade out, and then we can use the graph mapper again. So if we double click and type graph mapper, or only graph, it comes up, and I want to use a Bezier curve this time. So graph types Bezier curve. And from experience, I know that it's very good to increase the x value. So, I mean, the border of your curve is going to be here in Origo. That's 0, 0. So the distance from the curve to the where the fade out ends is actually the X value. So if you double click and go to the X value and type, for example, 5, that will be a much better situation. But how do we measure the distances? So there's something called curve closest point, which then determines where all the points are in relation to the curve. So if we take these ones and take the curve and put it in, we have a lot of stuff going on. So now we have we can measure distances or pick the curves that are closest to, pick the points that are closest to the curve that we have drawn. And we can simply see here also when we hover that the distances are actually being measured in this component. This is great because that's what we're doing here as well. So if we channel that into the graph mapper, we should be able to combine these somehow to affect the radius. So if we, and how do we do that? Well, we simply multiply actually. So if we multiply this list with this list, it's going to be fine. So we go to maths and we go to multiplication and simply multiply these together and put them into the radius. And then we have something here already. Oh, here is something. Now nothing happens. Why? Well, it's because we forgot to graph this one. This is something that, well, I almost made it on purpose now, but you see the difference. If you go in here and graph, you right click and you go to graphed, and something completely different happens. If you can take that out again. The thing is, it looks strange still, doesn't it? It's because there are settings going on here. So we need to go back to the original file, the original rectangular grid, and just simply increase it a little bit. Like that, maybe. And then we can increase the whole thing we did, like that. That is what I wanted to show you. And then you can start playing around with this to see how it works. So, thank you.